video, I'm going to give a short introduction on linear regression. Suppose we collect data from a population and measure the values of two variables, x and y. So on the right here, I have written down a data set with 12 data points. x1, y1 represents the first observation, x2, y2 is the second observation, x3, y3 is the third observation, and so on up to x12, y12. So the data might be the data on 12 farms. X is the number of chickens in the farm, Y is the number of eggs collected. Or it could be data on 12 students. X is the number of hours they spent studying for a math test, and Y is the math score that they got. And so often we are interested to see if there is any relationship between X and Y. And one way to see that is by drawing a scatter plot like what I have on the left. And the scatter plot might indicate that there could be a relationship between X and Y. And in the picture I've drawn, it seems like there could be a linear relationship between X and Y. Now, what line should we draw? A line like this is clearly not right because it passes nowhere near the data points. This other line that I draw seems more plausible. But the question is, how do I know whether it is the pink line or the gray line that is a better fit to the data set? And so people have to come up with a way to figure out what is the best line that will pass through the data points. Before we get to that, it is useful to talk about some notation. We use xi, yi to represent the data observations, and the I can go from 1 to n, so it means that we have a data set with n data points, and if I is 1, we have x1, y1, which is the first observation. If I is 2, we have x2, y2, the second observation, and so on. And in this case, we have n observations. If we remember the example from the previous slide, n will be 12. But in more general cases, we usually just let n to represent the number of data points that we have. Now, if I want to fit a line to the data, I need to have an equation for the line. And we know that an equation of a line is given by y equals to ax plus b. A is the slope, b is the intercept. But since y is already used for the actual observation, we use y hat, y with a little thing here, to represent the y value for the line. And so so here I have a picture with 3 data points. That's a very simple case. And let's say this is the line. Okay. Now the first dot over here corresponds to x1, y1. The second dot over here corresponds to x2, y2, the second data point. And the third data point is at x3, y3. Right. Now if I have this black line, we want the line to be as close to the points as possible. And the way to quantify how close it is to think about this vertical line between the dot, between each dot and the line. Now the height here is given by y hat 3, right? So this one over here is y3, but this height is y3 hat, and this y3 hat is given by ax3 plus b. Similarly, this height here is y2 hat because it corresponds to the second observation and is given by ax2 plus b. And this third point here is y1 hat equals to ax1 plus b. So remember that the y value correspond to the actual observations, and the y hats correspond to the values on the line. So y1 hat is here, y2 hat is here, and y3 hat is here. And in order to find the best line, we are trying to find an equation for the line. In other words, find a and b so that this vertical distances are as small as possible. And so how do we find the best line? We want yi hat to be axi plus bi. And we want the vertical lines to be as small as possible. The vertical lines are what are called the residuals. It's what is left over. And we represent the residuals using R for residuals. So this is the second residual corresponding to the second data point. A residual is just the actual observation, in this case y2, minus the observation from the line. So it is difference between y2 and y2 hat. The residual here, R3, is equals to y3 minus y3 hat. And this residual here, R1, is equals to y1 minus y1 hat. And so the criteria for finding the best line is to take each of the yi's, subtract the yi hat. You notice that some of these will be positive, so like R1 is positive and R3 is positive, but some of these are negative, so R2 is negative. So we take the square to make it all positive. I'm summing all of it together, add them up, I from 1 to n, in this case 3, and I want to make this quantity as small as possible. And remember that we have the equation for yi hat, so this is the same as sum yi minus yi hat is actually axi plus b, so it's minus axi minus b squared, and we want to make this quantity as small as possible. And so the way to find the intercept b and the slope a is to find values that would make this quantity as small as possible. And there are ways to do this using calculus, which I won't go into, but that's the procedure. We have the data points, all the yi's and the xi's, and we use this equation, this quantity, and we find a and b that makes this quantity as small as possible. Now, suppose we have found the values of a and b so that we know that yi hat is equals to axi plus b. We can then use this equation for prediction. If, for example, I'm interested in what the y value would be if x equals to 3, then all I need to do is to put 3 into the equation. So suppose this is 3 over here, then all we are doing is going up to the line and reading off the y value. Right? And so that's how you would do prediction. Once we have found the values of a and b, we then have the regression line. You give me any x, all I need to do is to plug it into the equation and it will give me a y value. How do we interpret this line? Well, this is just the equation of a line, and the way to think about the line is the same as you would do with any other line. If I have x equals to 0, then I know that y hat is equals to b, since b is the intercept. And since a is the slope, if x increases by 1, I know that y will increase by a. That is just the usual interpretation of a slope and an intercept. So given the line y hat equals to a, x plus b, we can then describe how the values of y depend on the values of x. Alright, that's all for now. Thanks for watching.